Welcome to the 3R booth, IMTS 2022. Back after 4 years of COVID. We're showing the System 3R Work Partner 1 Plus automation cell. We're set up today to change 80 macro electrodes and 20 macro magnum pallets into a mock-up of a Sinker EDM machine. We've got macro in the headstock and macro magnum on the table. Very productive alternative for people who want to run their machines at night. In this case, we're set up to load one mock-up machine, but this is designed to load a machine on the opposite side as well. So this robot could be shared between two machine tools, EDMs, wire EDMs, milling machines, grinders, lasers, anything you need to change a part in, or if you need to change something in their headstock. That's what this is designed to do. We're showing here is what we call the standalone B-axis for the wire EDM or for the small hole drilling EDM applications. And what this can be run on any machine that may or may not be equipped with an additional servo drive from the OEM. So say you had an older wire EDM machine and you only had 4 servo drives in it. I can't run a B-axis because there's nothing to drive it. This works off its own programming box here. So I program the standalone box, input an M code from the EDM machine itself, and it makes the next command at the B-axis. So for instance, I'm cutting this part, which represents over a week's worth of wire EDM work here. This is a lot of wire EDM. Anybody who's in the industry is going to look at the finish on this and the size of it and pretty much marvel at it. That was a gift to our old CEO from one of our customers. Every time he makes a letter, he's making an index. So it's cut, index, cut, index, cut, index. I don't need to drive it from the machine at all. All I need is at the end of the line of code, M code, subprogram, and cut. Small hole EDM. I'm cutting vanes for a jet engine. A lot of times they're drilling holes on the edges of those vanes. Every one requires a small movement in a radial axis. It goes on here, it could be the same thing. From a very simple control can operate this just by simply giving us an output of an M code. What we're showing here is actually 2 different systems. This is the 3R Delphin system. The Delphin system is a heavy machining chuck system. Each one of these chucks has the pull-down force of 60,000 Newton meters. That's 6 metric tons. So in this little area here, I'm clamping this pallet with 12 metric tons. It's not going anywhere. But what we're showing here isn't the clamping force of this chuck. What we're showing is the addition of these adapter ports. These ports are giving me the ability to put air into the pallet itself. So now the pallet is live tooling on top of the massively powerful chuck. This is a vacuum chuck. To run it, you got to run air through it. The air runs through a venturi and creates a vacuum, and I can pull a part down onto this plate for machining. The adapter ports give me the air I require. This is a pneumatically released vise. It's always in a locked mode, just like the chuck is. When I'm not adding air to clamp that chuck, I'm taking air away. So it's always in a clamp mode, it's always in a safe mode. This vise is the same way. I can't get the part out of there because there's no air to it. But when I add air, it releases the vise. I can put the part back in, and away I go. If I had this automated in a cell like one we just looked at over here, I might have a dozen of these larger pallets that I'm changing. But I may also want to machine something on a smaller pallet. For instance, the macro 54 millimeter pallet. Automation brings the larger pallet in, This automatically sends a signal to the control that we're working on a different plane now. We're not working on this platform, we're working at this level. So we open that chuck, the fingers come in here and pick up this part. Take the air away, and it's clamped. Very simple, very compact.